Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be picking up where I left off last time with trigonometric identities. Today we're going to be talking about the advanced topics, if you can call it advanced. So if you're still a little bit unconfident with the basic stuff, I'd say go back and watch my right-angled trigonometry video. But today we're talking about the law of sines and cosines. So let's take a look. Okay, law of sines and cosines. First up, here are all those basic right-angled trigonometry identities from the last video: sine, cosine, tangent, SOHCAHTOA. Remember that these are specifically for right-angled triangles, which is specifically not what we're going to be doing today, so keep that in mind. And so first little case in point here, we have this non-right-angled triangle ABC here, where I've given you the angle and another angle and an opposite of one of the angles. And I'm asking you to find basically the length of line AB. How would you do that? Well, you might say, I have no idea, because, without the rules I'm about to show you, I really don't think there is a way to solve for that other than getting a little ruler out and being really specific. But then if the drawing is not drawn to scale, then you really have no way of doing it other than having some math. And so with this particular instance, what you can see in the clue that I've given you to know which kind of rule that you want to use is we have an angle right here and its opposite. So this is what I'm going to call an angle opposite pair, and that is what's going to prompt us to use the law of sines. And what is the law of sines, you might say? Well, I'll show you. This right here is the law of sines. And so with the law of sines, that sounds either like a very serious and official rule or something from some sort of fantasy novel. So the law of sines is what the elves put forth when they came to this land to make sure that all the forest critters, sorry, never mind. But really, no, it's neither of those things. I apologize. It's just this, non-right-angle triangle property here where we have the sine of an angle over its opposite is, basically consistent. The ratio of that is consistent. So we have the sine of A degrees over A equals the sine of B degrees over B equals the sine of C degrees over C. And so this is saying that if we have a pair of the angle and its opposite, we can actually solve for, anything else given one or the other, either the angle or the side. So let's go ahead and solve with the example that I gave you using the law of sines. So we know that we have 105 degrees and 10. So that's going to be the sine, and it doesn't matter which angle this is. This could easily have been the sine of B. I'm just going to use A here since it's the first thing on the left. So this is the sine of 105 degrees over 10 is equal to, well, we want to find BC right here, which is this also, which is lowercase c. So that's going to be the sine of 55 degrees over c. And we can use a little bit of algebra here, multiply both sides by c, and so we have c sine 105 equals over 10 equals sine 55, and we can multiply by 10 to just get, I'm just going to do this sort of, I think you call this cross multiplying these days. That's c sine 105 equals 10 sine 55 degrees, and then all we do is divide by sine 105. And so we have c equals 10 times the sine of 55 degrees over the sine of 105 degrees. And this sort of unresolved fraction, sine of 55 is some sort of ratio decimal like 0.5 or something like that. And so is a sine of 105, but what you'll find is for most responses on these tests, they don't really want a number, they want this fraction. And that's going to be the way a lot of these answers are phrased. So that is enough for this case. Okay, and if that sounds like not a lot, it really isn't. You basically have this equation, and you fill in what you know, and you solve for what you want, and that's really all you need to do. And 95% of the time, in any event, you're going to be able to use a calculator on wherever this question occurs. So this should be a pretty simple and confident solve for most folks. And so let's move on to the next equation. So our next one here is called the law of cosines, and you can insert my same very silly, serious rule versus fantasy rule joke here if you like, but it's also just sort of a practical equation for solving some sides or angles with a non-right angle triangle. But for this one, it's more to do when you have an angle and its adjacent sides than it is for our previous one where we had an angle and its opposite pair. And so concretely, we have this equation, a squared equals b squared plus c squared minus 2bc cosine of a degrees. And you may initially think, oh my gosh, that's a lot of letters. But if you inspect it a little closer, I think that it's really not that bad. And so you may see something familiar in here in this right here is something you won't really have to memorize because you already know a squared equals b squared plus c squared. So that's just Pythagoras. And so the way that I remember this is we have Pythagoras minus some things. And so what those things are, we have lowercase a. And so what this is going to solve for is the opposite of the angle given. And so a squared is equal to the adjacents, b squared, c squared. So that's the things that are not opposite of a, the other two sides, minus 2 times those multiplied together, so it's just those again, times the cosine of whatever the angle is that you want, the opposite of. And I've just, for the sake of being thorough, rewritten them for each of the other opposites. So a squared, c squared, and b squared, those are all just how you would solve for an opposite given an angle or an angle or an angle. So let's go ahead and solve an example. And so back to our previous triangle, I've just sort of moved some stuff around. And so in this case, we have c, and we like this right here. And so we're going to say c squared equals a squared plus b squared minus 2ab cosine of c degrees. So Pythagoras minus some stuff. And so we're going to say c squared is equal to the things that we know, which are 10 squared plus 9 squared minus 2 times 10 times 9 times the cosine of 55 degrees. And if we want c by itself, all we have to do is square root both sides. And something that looks like this just writing all this all out here. This will absolutely be an answer that you'll see on these tests. So don't feel uncomfortable with selecting this big unresolved, radical here, because a lot of what the test wants you to do is to just show that you understand the equation and the concept. They don't particularly mind that you are a human calculator and can get these values. You may be doing something like that in the equation examples that we do in a minute, but aside from the point, usually the answers that you will see will look like this. So let's go ahead and apply this knowledge to some example problems. Okay, first example problem here, zoomed out a bit to make room for my face and the question, so take a look. All right, let's take a look at this one. So in the figure below, the distances between the two pairs of towns are shown, as well as the angle formed at Muir, which has a measure of 107 degrees, which of the following values is closer to the distance in miles from Newton to Lehman. So that's going to be this side right here. And so what you'll notice is that we have an angle and 2 adjacents, which means we need to use the law of cosines. And so what we have here is, and I said here's the sine of 107 and the cosine of 107 just to say, should we use the law of sines or law of cosines? And so since we have an angle and 2 adjacents, we're going to use the law of sines. So that's going to be this side, let's just call it c squared for consistency for the last question's sake, equals a squared plus b squared minus 2ab cosine of c degrees. And so that's going to be 24 squared plus 10 squared minus 2 times 10 times 24 times the cosine of 107 degrees. And we're going to square root all of that, and that's going to equal our side there. And so, I didn't have this big unresolved list of letters because I wanted to show that occasionally they do this on the test, just to show you now you have a look at both unresolved answers and resolved. And so you type this into your calculator and you get something that's pretty close to 29. I think it's 28.5 or something like that, which gives us the answer D. Okay, here's our next problem. Take a look and see what you can do. All right, let's take a look. So in this case, it's a little confusing because it doesn't look like we have anything. So what we then say is, well, we don't have an opposite or an adjacent, but we actually do, because we know since this is a triangle, we have 65 degrees and 45 degrees, which together is 110 degrees. So that means that this angle right here is 70 degrees. And so, here's our pair. So what we will be using is a law of sines. So we're going to say the sine of a degrees over a equals the sine of b degrees over b. And since we're really only worried about 2, I'm just going to stop there. So this is going to be the sine of 70 degrees over 130 equals the sine of, we want to know how long the string is. So it's the sine of 45 degrees over, let's just call that b. And so just like with our previous example, we're going to do b sine 70 degrees equals 130 sine 45 degrees. And then we're going to say that b equals the sine of 130 times the sine of 45 degrees over the sine of 70 degrees. Bring that up here. And using my calculator, the sine of 45 degrees is about 0.71. And the sine of 70 is 0.9, let's say 94 about. And using my calculator to resolve this, this is just 130 times 0.71 divided by 0.94. That's going to give me 97.8. So that's around 98, which gives us the answer C there. And so you may argue this is almost more difficult than what you would see on any test, but it's always better to be over. Okay, that's it for this video. It's kind of great that the tests consider law of sines and cosines to be advanced topics, because hopefully you've been able to see that they're really not that advanced. The hardest part about them, for the most part, is just remembering what they are. And so if you basically have that knowledge, you get that point. And hopefully this demonstrates the value of preparing for these tests and the value of what a tutor can give you in making sure that you know specifically which equations you need to be successful. So if you found this material useful, we hope that you'll like and share the video and subscribe to Quad Education. If you require some tutoring to figure out which of these equations you need to know, we're happy to help. Thank you for watching, and I hope you have a great day.